Hey guys, so I'm going to go ahead and teach you how to do these last few problems through a video since I'm not able to be there with you today. Okay, so we're looking at part D, so we're on the second page here. We had done these last week. So we have an equation 132 equals negative 4p, and before we left on Thursday, I asked you what was different about this equation than the ones we've seen so far. And we figured out that one of the things was that it's not in the same order as it was before. Normally we had the variables on the left side rather than the right. Well, if you want to, you can always turn this around, and that's called the symmetric property of equality, and you'll learn more about that in algebra next year. But it's just the fact that this is saying the exact same thing as this. It doesn't matter what side of the equal sign the expression is on. It's still equal, so these are still the same statement. The other thing that's different is that this coefficient, so that's a number being multiplied by the variable, is a negative. We haven't had that yet. So remember, this is multiplication here. The operation between this negative 4, which is the coefficient of the term with p, or the p term, is being multiplied by p. So this is multiplication. So remember, to solve for a variable, p, we need to undo the operation. The operation is multiplication. So to undo multiplication, we divide. So even though this is a negative number, that doesn't automatically mean that we're adding. Adding does not undo multiplication. Division does. So we're going to divide. But this time, instead of dividing by a positive number, we want to divide by a negative number because that's the coefficient of p. So we're going to divide both sides by negative 4. And we're going to use that bar notation, using this to show we're dividing. And then just like we did last week, so this kind of cancels out. Negative 4 divided by negative 4 is 1. Or you can just say that negative 4p divided by negative 4 is just plain old p, or 1p. You can put the 1 in front if you want, because it's truly there. And then you're going to need to grab a calculator to figure this one out. So we're going to do 132 divided by 4, negative 4. So remember, a positive divided by a negative is going to end up being a negative. And then 132 divided by 4 is 33. So our answer is negative 33. So I'm going to box that up. But I do need to check my answer. So remember, we write check. And then we're going to rewrite the equation exactly. But instead of p, I'm going to replace it with the negative 33. And I'm going to put it in parentheses since it's multiplication here. So I'm showing that I'm substituting in for p this value of negative 33. So that's what I'm saying p has to equal. And I'm going to put a question mark above the equal sign because I'm not really sure if I'm right yet. Maybe I plugged in something wrong or did something wrong. Okay, so then once you grab your calculator and go ahead and type in negative 4 times negative 33. And again, this is another time that is really important actually to use the calculator because of these negatives, because sometimes that throws us off. And I guarantee you that a single negative, especially when we get to problems that are more complicated, is going to throw your whole answer off. And it'll make it a lot harder to go back and fix once we get to more complicated problems. So you need to pay attention to negatives and catch those right away. When we do problems later, the first thing I'll always say if somebody checks their answer and it doesn't work out is look to see if you missed a negative. That's always the thing I say to check first. So that's why using a calculator here is really helpful. So you should put in the calculator 132 divided by negative 4 to make sure your result ends up negative like it's supposed to. And then negative 4 times negative 33 is a positive 132 because a negative times a negative is a positive. So that checks out. So our answer is correct. P is equal to negative 33. And if you want, you can turn it around like this. I generally like to have my variable on the left side, but it's not necessary. This is acceptable. Okay, that's it for the 4 different types of operations. We did addition and subtraction on the previous page, and on this page I showed you a multiplication and division given in different ways. So we had the multiply by reciprocal, we had the one where we just divided, the one where we just multiplied, and another one we divided but with a negative coefficient. So let's go ahead and go on to example 3. Now this one And I want you to underline, box, or do something, highlight this negative variable here. Because this is an example of problems where the variable is negative. So for this first one, part A, I can see that I have negative x is equal to 100. Well, isn't that just my answer? And the answer is no, because I want to know what positive x equals, not negative x. So there's lots of different ways you can look at this. We can just kind of reason what the answer is. This essentially is saying the opposite of x is 100. So what would regular x be? It would be negative 100. So hopefully you can see why, but I'll go ahead and keep explaining why here, because the opposite of an opposite is, a positive. So the one way we can look at this, though, and actually solve it is remembering that there's a 1 here. The coefficient, and I want you to write this down, coefficient of x is negative 1. So we want that to be a positive one. We want it to just be plain old x. So in order to do this multiplication, we're going to divide. So we're going to divide each side by negative 1. And then dividing by negative 1 is really easy. Negative 1 divided by negative 1 is a positive 1. So on the left side, we're left with just plain x. And then 100 divided by negative 1. Now ignore the negative first. 100 divided by 1 is just 100. Any number divided by 1 is itself. Okay? But since it's a negative 1, that makes it a negative 100. So our answer is x is equal to negative 100. So we need to check this, and I'm going to show you one more way to solve it. We're going to check. So make sure you be careful here. This negative is different from this negative. These are two different negatives. So you must write them both. So first, we're going to write negative. Okay, now we write x. It's negative x, or opposite of x. So opposite. Now you write x. What is x? It's a negative 100. So oftentimes when we substitute a value for a variable that's negative, putting it in parentheses is really helpful because that helps us see that we have negative x. So negative of negative 100 because x is negative. So it's a negative of a negative. Is that really equal to positive 100? And then the answer is yes, because look, a negative of a negative is a positive. Okay, you're subtracting a negative. So we get 100 is equal to 100, and then our answer is correct. So essentially it's saying the opposite of negative 100. The opposite of negative 100 is indeed positive 100. That's what this statement is saying. Now, if that doesn't make sense to you or you don't like dividing by that negative, one thing you can do, which you got to be careful here, is use addition and subtraction to help you out. So since I want this to be a positive number, what I can do is actually add x to both sides. So I'm going to keep track of my equal sign here. So look, these are like terms. A negative 1x, because there's really a 1 there, plus a positive 1x, zeroes out. That becomes 0. Now, before I told you you don't have to write the 0. Here you do because there's nothing else left on this side of the equal sign. If there's no other term, then you have to write 0. So like before we had I can't remember what the problem was, but like x plus 8 equals 10 or whatever. When we subtracted 8 from both sides, that zeroed out. So I told you did not have to write the 0, but the only reason you didn't have to write it was because we still had an x on that left side of the equation. Here we literally have nothing left, so you have to write 0. You can't leave one side of the equation blank. So equals, now this is something you haven't seen before, but 100 and x are not like terms, so we can't combine them. So we can only simply write them side by side. So 100 plus x. It's kind of like y equals mx plus b. When you have y equals like 2x plus 3, you have to leave it like that. You can't combine the 2x and 3 because they're not like terms. But you can have them sitting by each other with an addition sign between them. So that's what we have over here as well. Okay, so now this is kind of like when we were trying to get the variable by itself on previous problems like this one, we had the variable on a side with a number, so we needed to get rid of that number. So now we have x here on the right side with 100. I want to get rid of that 100. I want to make it 0. So I'm going to subtract 100 from both sides, because what you do to one side, you have to do to the other. Then you have the like terms 100 and negative 100, and those will zero out. And again, this time I don't have to write 0 because I'm going to just write x, since I actually have that x left over. Okay, then on this side, 0 minus 100 is negative 100. And then look, there's my answer. X is equal to negative 100. I hope that you see the first way is a lot easier, but that doesn't make this way incorrect. It just takes more steps. Okay, so that was one example. So we have another example we're going to go over here. And this time, the only difference is, again, well, we have a couple differences. Variables on the right side again, and then this number is negative. Over here, the number was positive on the opposite side. So let's do the first strategy. Okay, so remember this is actually a 1, so this is negative 1 times r. So I'm going to divide by negative 1 to both sides. So again, this negative 1 divided by negative 1 becomes 1 because we're dividing. So that reduces to 1, so I get 1r, or just r. And then again, using your calculator is so helpful. A negative divided by negative becomes a positive. So negative 7 divided by negative 1, the negatives are going to cancel out, and then any number divided by 1 is itself. So this is going to be a positive 7. And that's our answer for r. And then we need to check. So we have negative 7. Again, I'm just copying down that equation exactly, except where I see my r, I'm going to replace it with what r is equal to. So look, be careful again. You have that negative is not part of r. We're saying the opposite of r. So we have to write that negative. And then since I have that negative, I'm going to go ahead and use parentheses and then plug in r. r is a positive 7. So I'm going to plug in that positive 7. Question mark. So this is saying, is negative 7 equal to the opposite of positive 7? And of course, the opposite of positive 7, there on the right side, is negative 7. So negative 7 is equal to negative 7. So this is correct. So r is equal to a positive 7. So essentially our original equation was saying that opposite r is equal to negative 7. So then regular r must be equal to a regular 7. So anytime you're left with something like this where the variable is there's still a 1 there, there's not like any other number there, but it's negative, you'll always want to divide by negative 1. So let's just write that here. We're going to say divide by negative 1 to get rid of a negative. So if the only thing you need to get rid of is a negative sign, just divide each side by negative 1, and that'll get rid of it. All right, we're going to move on to the next page. Now we're working on two-step equations. So with two-step equations, we have more stuff going on. So we're going to isolate the variable by undoing the operations done to the variable in opposite order. For example, I've got an equation right here. So it's 7x plus 2 is equal to 16. The variable x is first multiplied by 7. So if I plug in a number for x, I first times it by 7. Think of this as a rule with y equals mx plus b. If I were to plug in a variable for x to get y, the first thing I would do would be to take my x times 7 and then add 2 to it. So 7, take my x times 7, then add 2. And then I'm telling you my result is 16. So I took a number, multiplied it by 7, then I added 2, and I got 16. So to go backwards, I need to do the opposite operations backwards. So I first need to undo this operation since it was the last one I did. So I'm going to subtract 2. That'll undo this operation, and then I undo multiplying by 7 by dividing by 7. So that's how I'm going to get back to my original number. So we're going to do this algebraically of steps, but let's go ahead and figure out what the answer to this would be, just thinking about it that way. So I took a number times 7, it added 2 and got 16. So now I have 16. So to go backwards, I'm going to do the opposite operations. Instead of subtracting 2 or adding 2, I'm going to subtract 2. Okay. Now I had gotten that 14 by first multiplying my original number by 7. So I'm going to take that and undo that by dividing by 7 to get 2. So my original number must have been 2. So I can check that. So 7 times 2 plus 2, is that really 16? 7 times 2 is 14. 14 plus 2 is indeed 16. So that's what we're going to do, but we're going to do it algebraically and show doing the steps to each side. So let me erase this so we can have some room to work down here. And then I want to fill in the notes up top too. So it says, so undo the operations in reverse order. First subtract 2, opposite of adding 2, then divide by 7, which is the opposite of multiplying by 7. So let's look at this first one. One strategy that's really helpful is to circle the term that has the variable. So notice on the left side there are 2 terms. 7x is a term and 13 is a term. This is called a constant term because it's just a number, and this is an x term because x is the variable that's present. So we call this the x term. Since we're solving for the variable x, we need to first get the term with x by itself. When we were doing one-step equations, we didn't have to really worry about that because it was only with one term. It was either just a 1x plus a number or it was just x times a number. Here we've got both things going on. So the first thing we want to do is isolate the term with the variable. So go ahead and circle 7x. That's the term with the variable. So I want to get that by itself on one side first. So I want to get rid of this 13. So in order to get rid of 13, I need to make it 0. So I'm going to subtract 13 from both sides. So you need to write this exactly as I do. Remember, you don't have to use this line, but it helps you keep track of your equal sign. So it is very helpful. So once we subtract, we can see that these are like terms and they zero out. 13 minus 13 becomes 0. I don't have to write the 0 because I still have stuff left on this side. So what's left on that side is 7x. Don't forget to write your equal sign. And then on the right side, I can combine these because they're like terms. So 76 minus 13 is 63. Now notice we're down to a one-step equation. So I had a two-step equation, I did one of the steps, and now I'm doing the second step. So I've got 7 times x is equal to 63. So now I subtracted to undo this addition, and so now I'm going to divide to undo this multiplication. So now I'm going to divide each side by 7. Because when I divide by 7, 7 divided by 7 is 1. So 7x divided by 7 is just x, or 1x is equal to, and then I just do 63 divided by 7, which you guys should know is 9. And so my answer is 9. So notice that whole working backwards thing. If I were to plug in a number for x, like a rule for y equals mx plus b, I would first multiply it by 7, then add 13. So now I do exactly backwards and opposite. Last thing I did was add 13, so the first thing I'm going to do is subtract 13. And then before that I had multiplied by 7, so I'm going to divide by 7 to get back to my original number. So we have to check. Now this is where it's getting more and more important to check. So I'm going to copy this equation exactly, except I'm going to replace x with what I'm saying x is equal to. And I'm going to put it in parentheses too. So 7, and then parentheses, my 9, which is my x, plus 13 equals 76. So you can see that that's just the same exact equation. That's just 7x plus 13 equals 76. But I'm replacing that x with 9. Actually, I'll go ahead and color code this too. So I'll make this blue. All right, and then I need a question mark above the equal sign because I'm really not sure if this is right. Even more so now since there's multiple steps. So when we do the checking here, we're not going to do stuff to both sides like we did when we were solving equations. Because we don't have to. That's just silly and makes for more mistakes. We want to just evaluate this side or figure out what this is equal to. So it's kind of just like if, again, we made a table up here and we were plugging in 9, and so 7 times 9 plus 2, and we were just figuring out what the output would be. It's not the same equation though, so it's not plus 2, it's plus 13. So we have to follow order of operations. So this is multiplication, so we have to do that first. 7 times 9 is 63. Plus 13. Is that really equal to 76? So notice I'm carrying my question mark because I still don't know if it's right yet. And then I have recommended this to you before to use a calculator to make sure you're not making silly mistakes. But 63 plus 13 really is 76. So 76 equals 76, and we make a check mark and show that yes, that we confirmed that it works. So notice that all we did was keep working until we couldn't anymore. We wanted to combine all the like terms we could. So we're just evaluating or doing those operations here to see what if that number really is equal to this number. So again, our final answer is not 76, it's x equals 9, but this is proof that our answer is true. So if you have all this work, and again, you're going to get faster at them and it's not going to take as long, but if you have all this stuff, then that's going to be a 4. Let's go ahead and do this next one, part B. So again, my first step is going to be circling the term with the variable. So I'm going to circle this term with the variable. Now notice that this coefficient is -3 of the variable, of the term with the variable p. The coefficient is a negative number. So first I want to get this term by itself. So I could ignore the -3. I just want to get this term by itself. So I want to get rid of everything else. So everything else is this -19. So I want to make that 0. So to make a -19 0, I'm going to add 19. And what you do to one side, you must do to the other. So one more reason I have you do this or recommend it is because some people will do things like this, where they will write plus 19 right here. So notice that's adding 38 to the right side of the equation. This is the right side of the equation. And adding nothing to the left side. That's not going to work. That's not going to be equal anymore. It has to be to each side. So that's another reason using this helps, is keep track of the equal sign and making sure you do the operation to both sides of the equation. Okay, so now I'm going to combine these like terms. So -19 plus 19 becomes 0. I don't have to write the 0 because I'm left with stuff on the right side still. I still have the -3p left on the right side of the equation. Equals, on the left side of the equation, I'm going to combine these because they're like terms. 20 plus 19 is 39. Okay, again, now we're down to a one-step equation. We've got this -3 multiplied by p. So to undo multiplication, we divide. So we're going to divide by that coefficient because I want the coefficient to be 1, so I'm going to divide by that number. So I'm going to divide each side by a -3. On the right side, the -3 divided by -3 is just 1, or that cross reduces, right? Or reduces to just 1, or 1p, or you can just write p. And then again, use your calculator to make sure that you're doing this correctly. 39 divided by a -3 is going to end up as a negative. Okay, so it's a negative, and if you put it on your calculator, it is 13. So -13. Okay, so that's what p is equal to, -13. So again, I like to flip mine around, but you don't have to. We need to check our answer though. So we're going to say check. So everybody's doing this with me. Check. And then we've got 20. So we're copying exactly the same equation, but we're replacing p with -13. So 20, is that really equal to negative 3 times our p? So I'm going to put this in parentheses, which I'm saying negative 13 is the answer, minus 19. So is 20 really equal to negative 3 times negative 13 minus 19? Because that's what my question was. 20 is equal to negative 3 times what number minus 19? So we're saying that number is negative 13. So let's do it. So the left side we don't need to do anything with because it's just a number. So we're just going to keep carrying that through. But we have to do the operations over here. So we need to figure out what negative 3 times negative 13 minus 19 is. Order of operations says we have to multiply first. So negative 3 times negative 13. Again, use a calculator just to be sure. But a negative times a negative will end up with as a positive. And 3 times 13 is 39. So this is a positive 39. And we still have to write that minus 19 because we haven't done it yet. And then we can simplify that. 39 minus 19 is indeed 20. 20 equals 20. So we just confirmed that our answer of p is equal to negative 13 is correct. Okay, so we're going to do one more here. All right, so this one we have a fraction, which is okay. We can deal with it. But our goal is still the same, to get the variable by itself. So first we need to get the term with the variable by itself. So go ahead and circle that term with the variable, which is 1/2 x. So again, this is one term, this is another term. So there's two terms on the right side, one term on the left side. So I need to get this by itself first. So everything that's not this needs to go away. So I want to make this plus 8 0. So to undo adding 8 or to make it 0 is to subtract 8. So I'm going to subtract 8 from both sides. Remember, 8 minus 8 here, this is what I planned, this is what I expected, was that to become 0. And again, I don't have to write it because I still have stuff on that right side of the equation. So I'm going to write 1/2 x because that's what I was left with. And then on the left side, I can combine these because they're like terms. So 14 minus 8 is 6. So my equation is 6 is equal to 1/2 x. Now notice this is a fraction being multiplied by a variable. We had an example of this on the previous page where when we had a fraction, the 5/2 multiplied by the variable, instead of dividing, we multiplied by the reciprocal. So we're going to go ahead and do that there because I know that it's the best way. It'll create the least amount of errors. So let's try that. You can divide by 1/2 if you want. I'm not going to stop you, but I'm going to recommend you do it this way. So this is 1/2 times x, so we're going to multiply by the reciprocal. So the reciprocal of 1/2 is just the flip. It's 2 over 1. Because you can see that if you multiply 1/2 and 2 over 1, that's equal to 1. Because this is 2 over 2. Because this is 1 times 2 and 2 times 1 is the same thing. Number divided by itself is 1, except for 0. So to get rid of this half, I need to double it to make a full x. I have 1/2 x, so I want to double it. So I'm going to multiply both sides by 2. So notice on this side, I can write this as a 2 over 1 since I'm multiplying it by a fraction. And then this side I didn't because I'm not multiplying it by a fraction. Now this might be hard for you to see, so one thing you can do is, since this is all multiplication, I can do it in any order that I want. So I can rewrite it like this. You don't have to, but it'll help show my point better here. So when we're multiplying this here, I can see I have 1 times 2, which is 2. 2 times 1, which is 2. So you get 2 over 2 is 1. So this becomes 1x like we expected. Multiplying a number and its reciprocal should result in the number 1. The other way you can think about it is to just cross reduce. So we're just doing 2 divided by 2 here. So this is 1 in the numerator, 1 in the denominator. Obviously that number would then be 1. Okay, so you could have just gone from here, jumped down here as well. And then we can see that on the left side we're just doing 2 times 6, which is 12. So x is equal to 12. Again, this is one that's important to check because it's a fraction in the problem, so we want to make sure we did it right. So again, we're writing the same exact thing except a question mark above the equal sign because we're really not sure if we're correct yet. So we've got 14, so 14 equals a half, and then it's times our x, so I'm going to put that in parentheses. What our value for x is, we're saying it's 12, and then plus 8. So I'm saying the number that you times by a half and then add 8 to get 14 is 12. So let's make sure it's right. So order of operations says I have to do this multiplication first. Since I'm multiplying by a fraction, I'm going to go ahead and make 12 into a fraction like that. And then look, this is just 1 times 12 is 12. That's in the numerator. And then 2 times 1 in the denominator is 2. 12 divided by 2 is 6. Or you can just, cross reduce. Divide by 2 is 1, divide by 2 is 6. So you get 6 plus 8. Is that really equal to 14? And then you have to do this last operation. You cannot make me do it. You need to do it. 6 plus 8 is indeed 14. So we'll check mark that and show that yes, that is correct. Okay, I'm going to go ahead and stop with you guys since I'm not there, but I encourage you to try the next one on your own since you have time, or you should. Try part D. It's a little tricky here because of this negative, but just know that if you do plus and negative, that'll help you. But I will make sure to go over this one with you tomorrow, and then I do not want you to do the back side. I will do that one with you tomorrow. Okay, so if you have lots of time left over, you give this a try, and you don't have anything to do, just do something quietly and listen to the sub, and I will see you tomorrow.